Hello class, welcome to Organic Chemistry Lab, Chem 3532, and this is our first virtual experiment video, and this experiment is experiment number 1 on thin layer chromatography. This is an outline of today's experiment. First, we will do an introduction to thin layer chromatography, which is the acronym TLC. Then we'll just present the purpose of TLC for this experiment. It will be two parts. One, examining the purity of a compound, and two, identification of an unknown compound. Next, we will examine a TLC result. We will go over the materials for TLC. We'll go over the procedure, visualization of the compounds, measure of retention factor, and your assignment. This slide is an introduction to thin layer chromatography. The acronym, as I defined before, is TLC. It is a method of separating chemical compounds based on their affinity for a stationary phase relative to a mobile phase. The definition of a stationary phase is about 1 millimeter of silica or alumina dispersed evenly on a hard surface such as glass, aluminum, or plastic. These stationary phases are regarded to be polar. The mobile phase is an organic solvent or a mixture of organic solvents. The most common solvents are the nonpolar hexane and the polar ethyl acetate. It is common to start with a mixture of 80% hexane and 20% ethyl acetate, and then adjust that solvent ratio depending on how tightly the analytes stick to the silica gel. An analyte is defined as a single compound or a mixture of compounds that you are to analyze. And the developing chamber is a sealed container used for the interaction of the mobile phase with the stationary phase. The purpose of TLC for this experiment is twofold. One is the examination of the purity of fluorine from laboratory number 2. You might recall that in laboratory number 2 you recrystallized a sample of fluorine that was contaminated with fluorinone. Here's an example of one of the results from Mike Yarden. Thanks, Mike, for your sample and your result here. Using TLC, you can examine the purity of your recrystallized product. If the TLC product contains one spot, it is considered pure. If it contains multiple spots, it is considered to be impure. Identification of an unknown compound is the second part of this experiment. In lab number 3, you use an acid-base chemistry to separate a mixture of two compounds. The first compound was neutral, and we don't know the identity of this compound. You might recall, this is from KG. You might recall laboratory number 3, the first compound, a lot of you gave me this yellow colored solution. So we don't know what that compound is. The second compound was benzoic acid, and it was separated by treatment with sodium hydroxide. Now this is the sodium hydroxide solution of benzoic acid. It actually has to be acidified to convert to benzoic acid. Using TLC, you can compare the first compound with the TLC of known compounds. If the unknown and the known have the same retention factor, then they are considered to be the same compound. Let's look at an example of a TLC result. On the right is a developed TLC plate. We started with 3 analytes, one labeled U as the unknown, 2 labeled K1 as the known sample 1, and 3 labeled K2 as the known sample 2. The analytes were spotted on the starting line number 1. They alluded to various positions in areas number 2, and then line number 3 is the solvent front, which is the distance traveled by the uninhibited solvent. The retention factor is calculated as shown in the red box, where retention factor is the distance traveled by the spot between position 1 and 2 divided by the distance traveled by the solvent from position 1 to position 3. Okay, I'm going to show in more detail how to deposit a sample of the analyte onto the TLC plate. So here I have the TLC plate. It is marked at the starting point with pencil, and I'm going to deposit the solution right here on spot X. This is the sample of Mike Yardon, lab number 2. This is the solution of his recrystallized product. All I do first is I dip the capillary pipette into the solution. This draws up some of the solvent, some of the solution, and then I touch this very lightly to the X spot. I like to do this 3 times. That's once. That's twice. And this is the 3rd time. Notice then I have a spot and that's been put on the paper. I can't see anything. Here, let me see if I can do this a 4th time so you can see how lightly I spot the solution. And I want to make a very small deposit of the solvent onto the plate. I have just finished spotting Mike's compound onto the TLC plate, and you can see that you cannot see the compound because his compound is colorless, and so there's no way to visualize it, except that we have a special type of TLC plate. It has a fluorescent indicator in it. So the fluorescent indicator allows me to use UV light to visualize the sample. So I've set up a UV light chamber with shortwave ultraviolet light. I'm going to take Mike's TLC plate and I'm going to put it into the chamber. And you can see his TLC plate. Here's a better view of his TLC plate. And you can see the dark spot. That is due at the starting line. That is due to his compound absorbed onto the TLC plate. In this video, I'm going to show how to prepare the developing chamber and to develop a TLC plate. The developing chamber has a piece of absorbent paper that helps keep saturated the vapor in the atmosphere above the solvent. We add in the solvent just enough to cover the bottom. Then the next thing we do is we take the TLC plate and we place it carefully inside the developing chamber. Now, an important thing here is that you do not want the solvent level in the developing chamber to be higher than the starting line. See here, we have the solvent level is below the starting line. The next thing I do is I put the cover on. Then what we do is we take the TLC plate and we place it in the developing chamber. We double check to make sure that the solvent level is below the level of the starting point for the TLC plate. So this is, and then what we're going to do is we're going to let the solvent travel up the TLC plate to about 3/4 of the height. So we're going to see, this is so far, it's been about 15 seconds. I'm going to put the cap on. And the next thing I do is I put the cover on. And I wait for some time until I see the solvent front go up about 3/4 of the way up the TLC plate. It has now been 2 minutes. Let me remove the cap. We see that the solvent has traveled about 3/4 of the way up the plate. Might be hard for you to see, but I see it right there. What we do is we pull out the plate. We mark where the solvent front is with a pencil, and then we gently wave the plate in the air to allow the solvent to evaporate. I've taken the plate, I've marked a little bit more clearly the solvent front, and you can see the starting point. You can see that there's no way to visualize any of Mike's compound because his compound is colorless. So then what we have to do is we have to put his compound into a shortwave UV light. So now Mike's compound is inside a chamber with a shortwave UV light, and you can see where Mike's compound is. It's just slightly below the solvent front. It's this nice, beautiful purple spot right here. So what I do is I take a pencil and I circle Mike's spot, and then I start to do my analysis after I've circled his spot.